Now we will start once more to talk about the evaluation of the quadratic forms. I'm sorry, the eigenvalues related to quadratic form. Remember with me how to get the symmetric matrix that I will use to get the eigenvalues for this quadratic function. First of all, is this a quadratic function? Is this a quadratic form? Yes. Why it is quadratic function or quadratic form? Because all the terms that I have a power of 2. Okay? Then I will start now. We are in R3, so mainly I will have X, Y, and Z. This is the matrix of the dependent variables. This is the 2 by 2 matrix that we will form. And here we will have the column matrix, which is X, Y, and Z. I will go for the first term, which is X squared. Remark that I have X here and the X over this there in these two matrices. So the first element will be, when, as I told you in the first lecture, this is number 1, number 2, and the number 3. Once you are talking about X squared, you mean the element 1, 1. So I will go to the element 1 and 1 and write -1, which is the coefficient in front of X squared. In a similar manner for the coefficients in front of Y squared, what the coefficient in front of Y squared? -3. It will be within the element 2 by 2. What's the element in front of Z squared? Okay, which is going to be 3 by 3. -1. So this is the 3 by 3 position, and it's going to be -1. For the element of X and Y, which is 1 and 2. XY, you will have 2 divided by 2. In all times, we divide by 2. So this is 2 divided by 2, it's going to be 1. I will write in 1 to 1 and in 2, 1 the same thing. Then I will go for the value in this place, which is XZ, 1, 3. XZ value, which is 2, also divided by 2, so it's going to come up to 1. So it's going to be 1 here and 1 in 3 and 1. Remaining YZ, which is the element 2, 3. YZ value is -2. So half of it will be in 2, 3, and the other half will be in 3 and 2. This is how to get the symmetric matrix that we will get our eigenvalues from this matrix. Okay, perfect. أنا دلوقتي عندي symmetric matrix بتاعتي. إزاي أقدر how to get the eigenvalues? It's really very simple. All I have to do is to solve, as I told you in the first lecture, this system of, or the determinant of this matrix, which is simply A, the symmetric matrix, minus lambda, the value of the eigenvalues, times a unit matrix from the same dimension, which means I would subtract minus lambda from the principal diagonal. So now I'm dealing with a determinant equal to 0, taking minus lambda from the principal diagonal. So it's going to be -1 minus lambda, 1 and +1. This is going to be 1. This is going to be -3 minus lambda. And for the last number, it's -1. This is going to be +1, -1, and -1 minus lambda. Solving this system or this equation, it will give me the values of this eigenvalue or the corresponding value of these eigenvalues. How to expand this determinant? Do you remember? I can do it in 2 manners. I can do it using Sarah's rule. I will go through it while we are working with the minors. And also we can use the cofactor method or the Gaussian method. If you remember, I will go with the first element, which is -1 minus lambda. So all I have to do is to take -1 minus lambda, eliminating its row and the column. Eliminate the row and the column with -1 and -lambda. What's the remaining? It's going to be the determinant. Okay, let me write the determinant step by step. So the determinant, once you erase the row and column, will be -3 minus lambda, then -1 minus lambda. This is going to be a -1 and a -1. In a similar manner, I will go for the second number, which is positive 1. But don't forget the sign rule. Do you remember the sign rule? Positive, negative, positive, negative, positive, negative, positive, negative, and so on. Okay? So I will have a negative sign here, which is assigned to this number, which is 1. Then I will eliminate the row and the column, and I will write the remaining elements, which is going to be 1. Are you with me? Negative 1, 1, and negative 1 minus number. Check mine. Okay, for the last minus, for the last one, I will get plus. This is the number, that's the last one. So it's the sign is going to be positive. As I told you, the sign rule is positive, negative, and positive. So it's going to be positive 1. I'm not going to write it. Eliminating the row and column. What's remaining is going to be a 1 and 1. Then negative 3 minus lambda, then minus 1. Are we all set? Equal to 0. Start to expand these equations. It's going to be really, very simple. All I have to do is to make cross multiplication or evaluate the value of this determinant. So I believe it's going to come up to negative 1 minus lambda, and then open your bracket. I will multiply the elements of the principal diagonal, which is going to be 3 minus lambda, 1 minus lambda, then minus 1. Am I correct? Then I will have a minus. I will open a bracket. I will have negative 1 minus lambda, then plus positive 1. Then I will have for the last one, 1 times negative 1, which is going to be negative 1. Then a plus over 3 plus lambda. Am I right? Okay. Then we can make things easier by multiplying negative lambda times negative lambda, which is going to be a lambda square. Negative lambda plus negative 3 lambda is going to come up to negative 4 of lambda. 3 times 1, positive 3, minus 1, so it's going to be plus 2. So this is actually the simplification of this guy. I believe here we can eliminate negative 1 and positive 1, so I will have positive lambda. I think here negative 1 plus 3 is going to come up to 2 plus lambda. And then I will try to expand and making more. Okay, so this is okay. I have here lambda, and that's lambda. And the sign is plus, so it's going to be 2. Plus 2 lambda. For this guy, I have now negative of 1 plus lambda. This is going to be, if we try to factorize it or leave it for the time being, it's going to be negative 2 minus 4 over lambda plus 2. This is going to be a plus equal to 0. I can see here I have 1 plus lambda, so if you take 2 as a common from these two guys, I will have 1 plus. Are you with me? If we take 1 plus lambda as a common from these two parts, we take 1 plus lambda from here and from there, I think I will have 1 plus lambda as a common. Open your bracket, you will have negative of this value, which is going to come up to negative lambda squared, then plus a 4 over lambda minus 2. Then from this term, you will have positive 2, and it's equal to 0. Now these two guys can cancel each other. I can take negative lambda as a common, so it's a 1 plus lambda, then minus lambda. From here, I will have taking negative lambda, I will have lambda minus 4 equal to 0, which leads to lambda equal to negative 1, or lambda equal to 0, or lambda equal to positive 3. Are we correct? Is everything correct? Yes? Let me check that once more. Of course, be careful, this is not an easy task to do. It needs a lot of focus and attention. Once more, as I told you, I will see, I'm seeing now I have 3 dependent variables, so it's going to be x, y, and z, x, y, and z. I will get the symmetric matrix. It's really very simple. Taking x squared, y squared, z squared on the principal diagonal. And for x, y, it's going to be the element 1 and 2, half of it in 1 and 2, and the other half in 2 and 1. Then x, z is going to be 1, 3, and the half is going to be in 3 and 1, and so on. Now we formulate this matrix. Now we can get the eigenvalues by subtracting minus lambda from the principal diagonal. It is already done. You have 2 options, either using Sarah's rule, I will talk about in the coming slides, or using Gauss method. Gauss method is really very simple, but you have to remember the sign rule of how to expand a 3 by 3 determinant. So I will take the first element and eliminating the first row and column, and this will give me this 2 by 2 determinant. Same way like, but don't forget that you have a negative sign here, so it's a negative. Eliminating row and column, you have 1 and 1, negative 1 and negative 1 minus lambda. Similarly like for the third one. Now expanding and trying to simplify stuff. This is what's going to happen once you try to eliminate and take lambda plus 1, exactly like what we did in here. And you will end up having negative lambda plus 1, lambda plus r. I think I have, this is going to be minus, I believe. So you will have lambda equal the results. No. This is positive. This is exactly like what it was. It's negative 1. This is positive, so this is going to be a negative 4. So probably I will have a missing value here for, or just a minor mistake for taking the negative sign. Here is 1 minus lambda. So I will have negative lambda squared, okay? Negative lambda squared, and negative times negative 4 is going to be positive 4 over lambda. Negative times 2, negative 2, and then I will have positive 2, this will eat each other. Then in this guy here, taking negative lambda from this one, it's going to be negative lambda squared, and the negative lambda times 4, it will end up having 4 lambda, this must be, okay. So you will have to check these results once more, okay? Just to check the sign. But by the end of line, I have now lambda, which is negative 4, negative 1, and lambda 3 equal to 0. If you remember the classification that we talk about the value of the eigenvalues, now I have all the eigenvalues less than 1. I'm sorry, less than 0. And one of them equal to 0. So this is going to be negative semi-definite quadratic form. So Q6, it's going to be a negative semi-definite. Do you remember, Dina? Okay, this is for the classification relative to the eigenvalues. The problem of the eigenvalues is how to deal with a cubic equation. One of the methods that we can use to deal with cubic equations is this case. Okay, so it's going to be, okay, so it's going to be, as I told you, negative semi-definite. I want you to try to solve this equation. I want to solve with you this equation. Because in general, once you try to evaluate the eigenvalues for a 3 by 3 determinant, you will end up having a cubic equation. So how to factorize a cubic equation? I will need to add this information or this information about how to factorize or how to solve a quadratic, a cubic function, a cubic polynomial. Okay. So just wait a second. Okay. Give me the coefficients of this cubic polynomial. Lambda q, and then minus 6 lambda square
plus 11 lambda.
Plus 11 lambda, then minus 6 equal to 0. So in another problem, if I wanted to evaluate the values of lambda, and I ended up with a general case like this one. Of course, trying to expand this polynomial with the plenty of trying to take a common factor step by step, and you were lucky enough that once you try to take here lambda plus 1 from these two terms, you ended up having lambda squared plus 4 of lambda and somehow. So taking lambda as a common, now you succeeded in factorizing into 3 values of lambda. So this is a special case by itself for the previous one. But the general case will be something like this. How to analyze a cubic equation. I will use 2 theories. I'm not really sure if you took them previously or not. The first of them is Descartes' rule of sign. This is in algebra. Descartes' rule of sign, which states, if you rearrange your polynomial in a decent manner, that means from the biggest power to the smallest and so on, then try to count the number of variations of sign in the coefficients. So let's do that. From positive to negative, that's an alternation. From negative to positive, that's another alternation. From positive to negative, that's another alternation. So how many alternations in sign I have? 3. 3 alternations in sign. What we mean about alternation in sign, the sign of the coefficient of the variable, okay? So now, if we try to do so, from positive to negative, that's a variation. From negative to positive, that's a second one. From positive to negative, that's a third one. Which means this equation probably will have 3 positive roots or less than that by 2. So it has a 3 positive roots or 1 positive root. So what Descartes' rule states is trying to speculate the number of positive roots. معايا شات? Okay, how to get these roots? If you have rational root, which is in the case that we are dealing with, it should be one of the numbers that that will come from factorizing the last number, dividing it on the first number. So I will go to the free number with no independent variable, which is 6. Try to factorize it. What are the multiplication of 6? It's going to be 1 and 6, or 2 and 3. These are the numbers that are the factorization of this value, which is 6. For the first coefficient, or the coefficient of the highest power, what's the coefficient of highest power here? It's positive 1. Also factorize it. It's going to be positive 1. Divide these values into each other. So all I have to do, this is the factorization of a 6, and here is the factorization of the coefficient here is just only 1. So the R values, or the rational roots, if exist, it's gonna be 1 over 1, so it's gonna be 1. 2 over 1, it's gonna be 2. 3 over 1, it's gonna be 3. 6 over 1, it's gonna be 3. And for my case, all of them will be positive. So if I try to evaluate the number of variations, and it's not 3, let's say it was just only 1 variation. For example, if I have positive lambda square, negative 6, negative 11, negative 6, then I will have just only 1 alternation. It means I will have 1 positive root. It will be probably one of these numbers. And the remaining roots, okay, it will be either negative roots or complex roots. The complex roots, I can't find them. And for the problems that you will deal with, always you will deal with problems with lambda real numbers. Are you with me? In this case, or in our case, okay? How to be sure that, or how to find the value of this eigenvalue, or a root for this polynomial. Just try to substitute by these values, 1, 2, or 3, or 6. If you substitute by any of these numbers and the result is 0, this is gonna be a root. So this even one value of these values. Start substituting with 1. So I will try to get B1. 1 cube is gonna be 1. This is gonna be a negative of 6. This is gonna be positive 11. Minus 6. The result will be 1 plus 11, it's 12. Minus 6 is gonna be 0. So this is gonna be 0. You are very lucky that lambda equal 1 is one of the roots of this polynomial. So this is an eigenvalue. How to get the remaining eigenvalues? The general method states that I can decrease the degree of this polynomial by dividing this polynomial on this value. How to do this division? I will use what's called a synthetic division. How to do a synthetic division? It's really very simple. I will take the coefficients of this metric, of this polynomial, which are 1, -6, 11, and the -6, just only the coefficients. And then I will try to divide them on +1. So here's 1, 1 times 1, it's gonna be 1, 1 plus -6. Remark, I do multiplication diagonally and I do addition vertical. So it's gonna be 1 times 1, it's gonna be 1. -6 plus 1 is gonna come up to -5. -5 times 1, it's gonna be -5. Then do the addition, it's gonna be +6. 6 times 1 is gonna be 6. The last number, or the sum, the last sum is equal to 0. Now start to write this polynomial, which is gonna be less than the given one by 1. Chat. Start, this is q to the power of 3. You find one of its roots. So once you divide, it's gonna be a second degree polynomial. I want to start the Dina from the left. So it's gonna be lambda square -5 lambda plus 6 equal to 0. Now for this quadratic function, we can analyze it, we can factorize it. Am I right? So start factorizing. So it's gonna be simply lambda and lambda. This is gonna be 3 and 2, both of them are with negative values. So it means that your lambdas are going to be lambda 1 equal to +1, and lambda 2 from this bracket is going to be +2, and lambda 3 is equal to 3. This is actually the case how to get the values of these cubic roots. If we are allowed to use our calculator, I'm not really sure at the second midterm and the final exam, are we going to be able to use our calculators? If not, probably some of our calculators, they can solve cubic equations. But if not, this is the case to hunt exactly the values of or the roots of a cubic equation. Do you read me? Once more, we were searching for the eigenvalues. Why we are searching for eigenvalues? We are searching for eigenvalues because it is the simplest way to find if you have positive definite, positive semi-definite, negative definite, negative semi-definite, or indefinite values, or indefinite type of your quadratic form. Okay? So if I have 2 by 2, it's going to be very simple, because once you try to get these eigenvalues for a 2 by 2, it's going to end up having a quadratic equation. You will be able to solve it. But if I have 3 by 3, you are in between two cases. Either your simplification you will be ended up having a special case of cubic equation, that once you take common factors, multiple common factors, you will be having some brackets multiplying in each other, so you will be able to get the values of these eigenvalues. The general case is to have something like this, and this is how to factorize it in order to get the roots, which are the eigenvalues. So I will go quick on this one once more for you, and if you need a revision on it, I will do it later. Okay? So first of all, if I want to solve a cubic equation with rational numbers, I will start by knowing if the roots are positive or negative. How to determine this? By Descartes' rule. How to do Descartes' rule? Try to write your equation in a decent manner, from the highest power to the lowest numbers, or to the lowest power. Then try to count the number of variation. If it is odd number of variations, that means this equation will have at least equal one positive root. How to get this positive root? Okay, so Descartes' rule, just to be sure that it has negative roots or positive roots. Now I'm sure I will have at least one positive root. Okay? It will give you 3 alternatives, but at least you will have just only one positive root out of three of these 3 positive roots. Okay? That's a point in Descartes. Once more, Descartes' rule of sign. The number of positive roots is the number of alternation in sign in your equation, or less than that by 2. So Descartes' rule for this equation states that I may have 3 positive roots, or maybe I will end up having just only 1 positive root. Bottom line, I will have 1 positive root. How to search for this positive root? Simply, I will go to the free value or the free term, the 6. I will factorize it. See what are the numbers that when multiplying each other will give you 6. It's 1 and 6 and 2 and 3. Same way like I will go to the first number or the coefficient of the highest element and I will factorize it, which is positive 1. Divide them on each other. So probably if I have positive root, it will be one of these numbers. And here, once you finish your problem, all of them are actually a factorization from 1 to 6. Do you read me? Okay, I've tried to make, how to know it's a root? Simply by substituting in this equation. If this equation equal to 0, this is going to be a root. This is why, Shad, I've started substituting by 1. When I started substituting by 1, the value becomes 0, so 1 is one of the roots of this polynomial. Now I know one of these roots. I need to decrease the degree of this cubic function in order to, or this cubic equation, I'm sorry, in order to completely determine the remaining roots. How to do this? I will make a division in order to decrease the degree from a cubic function into a quadratic function. عشان كده عملت الساينتيفيك ديفيجن. فاهميني؟ معايا متابعيني؟ قادرين تتابعوني؟ اوكي، لذلك رحت واخد الكوفيشنتس 1 ونيجاتيف 6 و11 ونيجاتيف 6 1 ونيجاتيف 6 و11 ونيجاتيف 6. بعدين I will divide them on 1. خلي بالك يا دينا، انا بنزل فيرست ال1 الاولاني بينزل يبقى 1. بعدين بعمل multiplication diagonally. 1 times 1 is equal to 1. بعدين بعمل addition vertical. نيجاتيف 6 و1 يديك كام؟ نيجاتيف 5. انت معايا؟ اعملي multiplication تاني. نيجاتيف 1 times 1 يبقى بكام؟ 11 ونيجاتيف 5 يبقى بكام؟ 6. Do it once more. معايا شباب؟ 6 اروح اضربها في 1 يبقى الرقم فين؟ بعدين بعمل addition vertical. لو لاحظتي الترم ده بقى بزيرو، عارفه ليه بقى بزيرو؟ لان انت بتعملي ديفيجن على one of the roots. لو الواحد ده مش روت لا يمكن الاليمنت ده يبقى بكام؟ الاليمنت ده مش هيطلع بكام؟ بزيرو. Do you read me؟ ده معناه بدل ما كنت بديل with cubic equation، now انا بديل with a quadratic equation which is lambda square minus 5 lambda plus 6. Now you can factorize it and you get the rest of the roots. Do you understand what I'm saying? Now I have the roots. All the roots or all the eigenvalues are positive. If this is a quadratic form, I got it from exactly the same steps. Now I have all of them are positive, which means I will have a positive definite quadratic form. Are you with me? Okay, perfect. I don't have to go further more than that. I believe this idea is very, very sufficient for the case of eigenvalues. Now I'm going to talk about the principal numbers. Stop. If you remember, early this morning, we talked about the quadratic forms. We need to classify them. So we are in between two methods for the time being, actually. The first method is to consider the coefficients, Ms. Chat. If the coefficients are positive, or some of them positive and negative, we know the classification of the coefficients. If we didn't succeed to classify, depend on the coefficients of this quadratic form, I will use the eigenvalues with all the methods that we did go through linear algebra, starting from how to get the eigenvalues, how to solve the cubic equation, to get these eigenvalues. What if we couldn't solve or deal with these eigenvalues? We need something else. So this is the third method or the third tool that you can use in order to classify your quadratic form, which will depend on the principal minors of the symmetric matrix that you will get from the quadratic matrix, from the quadratic form. معايا يا شباب؟ يبقى انا كده بتكلم على انهي ميثود؟ ميثود نمبر 3. تعالوا نشوف ازاي بجيب برنسبل ماينرز. بصي البرنسبل ماينرز let's say for this matrix، دي ماتريكس انا جبتها من كوادراتيك فورم. تمام؟ شهد انت عارفه يعني ايه جبتها من كوادراتيك فورم؟ يعني عملت ايه؟
يعني كان عندي فانكشن فيها
يعني فيها عندي اكس سكوير حطيته في الاليمنت 1 and 1، واي سكوير حطيته في الاليمنت 2 and 2، وهكذا زي ما احنا عملنا من شويه. دي الماتريكس بتاعتي. تعالى بقى نجيب البرنسبل ماينرز. لو انا هجيب البرنسبل ماينرز هيبقى عندي، لان ده 3 by 3، يبقى عندي برنسبل ماينرز of 1 degree، principal minors of 2, and the principal minors of 3 degree. The principal minors of the first degree will depend on the following: eliminating the first 2 rows and corresponding 2 columns. يعني لو انا عايز اجيب البرنسبل diagonals of order 1، بصوا هعمل ايه؟ معايا جميل؟ ده الديترمنت بتاع الماتريكس بتاعتي. بصي شكل همسح الصف الثاني والثالث، امسح معاهم العمود الثاني والثالث. So simply I will eliminate the second and third rows, and also I will eliminate the second and third columns. What's the remaining number? It's -1. So this is going to be the first principal minor of -1. In a similar manner, I will go for M2 and 2. How to get M2 and 2? I will eliminate the first row and the third row. Same manner, I will eliminate the first column and the third column. What is the number that you will have? -3. So it's going to be -3. Are you with me? Okay, the third first order minor, it's going to be eliminating the first and the second rows. And simply like I will eliminate the first and second column. So simply it's going to be -1. Or we can consider the first principal minors as the elements of the principal diagonal. Okay? The elements of the principal diagonal here are -1. صح؟ شباب صح؟ -1, -3 and mean and the -1. I will go now for the principal minors but of order 2. Now I will eliminate the third row and the third column. This is going to be the minor 2 by 2 that I will have. -1, 1, 1 and -3. Let's do it once more. شايفه الديترمنت بتاعي اهو. عايز اجيب الماينرز او البرنسبل ماينرز بس اوف سكند ديجري. هعمل ايه؟ هبدا هاليمينيت اللاست رو اللي هو ثيرد رو، واليمينيت معاه الثيرد كولم. مين اللي يفضل 2 باي 2 ديترمنت؟ شايفاه؟ اللي هو 1 -1 1 1 -3. طبعا اهو ده الشكل بتاعه -1 1 1 -3. If I try to evaluate it هيبقى -1 في -3 it's gonna be +3 -1 is gonna be 2. So keep it. تمام؟ عايز اجيب السكند ماينور اوف اوردر 2. ازاي اجيب السكند ماينور اوف اوردر 2؟ هاليمينيت السكند رو واليمينيت السكند كولم. لما اليمينيت السكند رو والسكند كولم، يا ترى ايه الماينور اللي يظهر قدامك؟ بصي هاليمينيت السكند رو اهو، هاليمينيت السكند رو والسكند كولم. مين الارقام اللي تفضل قدامك؟ -1 و-1 1 و+1 اه. -1 1 و+1. Try to evaluate the value of this determinant. So principal diagonal is going to be +1 minus the secondary diagonal. The sum will be 0. I will need to get the third order, or the third minor of order 2. Now I will have to eliminate the first row and the first column. Eliminate the first row and first column. تعال نشيل الفيرست رو والفيرست كولم. eliminate الفيرست رو والفيرست كولم. مين اللي هيظهر عندك؟ -3 -1 -1 and -1. Okay, here we go. -3 -1 -1 -1. Start multiplying. -3 times -1 is going to be +3. -1, so it's going to be 2. So these are the minors of order 1. These are the minors of order 2. I can evaluate the order 3 minors, which is going to be the complete determinant. How to evaluate this determinant? Now I will give you a Saras rule. How to evaluate using Saras rule. These numbers are -1, -3, and the -1. This is -1, +1, 1, -1, 1, and 1. this is the determinant that we are dealing with. بصوا يا شباب، شهد ده مش متاكد اذا كنت انت خدت ده قبل كده ولا لا. اوكي، ده نيجاتيف 1. How to use Faras rule. I will get the multiplication of the principal diagonal. اضرب دول في بعض. نيجاتيف 1 تايمز نيجاتيف 3 بوزيتيف 3 في نيجاتيف 1. يبقى الفاليو بتاعته بقت بكام؟ بنيجاتيف 3. لو انتوا خدتوا بالكم انه البرنسبل diagonal بيسيبريت this square determinant into upper triangle و lower triangle. Am I right? So take the base of the upper triangle in the vertex of the lower triangle. يعني ايه يا دينا؟ يعني هقول plus 1 times negative 1. This is the base of the upper triangle. 1 times negative 1 times the vertex of the lower triangle, which is positive 1. Do it once more, but on the other triangle. I will take the base of the lower triangle, which is 1 negative 1. 1 times negative 1. And multiply it by the vertex of the upper triangle, which is positive 1. يبقى تاني once more.
So دي كده دايما هيبقى نفسه عشان هو سايمتريك.
يعني ايه نفسه؟ مش فاهم السؤال.
يعني
ده اهو انا هضرب نيجاتيف 1 في نيجاتيف 3 في نيجاتيف 1. صح كده؟ بعدين بلس. اول حاجه البيز اوف ذا ابر تريانجل 1 نيجاتيف 1 تايمز بوزيتيف 1. بعدين بلس 1 تايمز نيجاتيف 1 تايمز 1.
ايوه، انا قصدي بقى ان البيز تايمز الفيرتكس هيبقى هنا وهنا نفس الرقم.
انا بتكلم عن الجنرال كيس. ماشي، مش السبيشال كيس. اوكي، بعد ما عملت ده هروح جاي عامل نيجاتيف و I will do the same but on the opposite direction in the secondary diagonal. يبقى في السكندري diagonal ده السكندري diagonal، ده الجزء بتاع السكندري diagonal. اتضرب ازاي؟ 1 times نيجاتيف 3 times 1. بضرب دول في بعض. بعدين بلس نيجاتيف 1 times نيجاتيف 1 times نيجاتيف 1 اهو. بعدين بلس 1 times 1 times negative 1. برضو اللور البيز of the lower triangle times the vertex of the upper and vice versa. These are the